Welcome everyone to the July 2023 National Newborn Screening Pilot Monthly Webinar. I'm Dr. Amy Brower. I'm a director at the American College of Medical Genetics and Genomics, and I'm helping out hosting the webinar with the rest of my colleagues on the ACMG team today. Just some housekeeping items that we always remind you, please mute yourself while others are speaking. Feel free to use the chat window if you want to ask questions during the presentation, but you can also save your questions for the end and unmute yourself and ask your question directly to our speaker. So we welcome everyone today. The webinar is being recorded and will be available on the MBSTRN website within just a few days after today. Today we have a presentation from a colleague at PerkinElmer and Revity with their new name, Revity. So Colin is going to talk to us about measurement of I2S enzyme activity associated with mucopolysaccharidosis type 2 in dry blood spots using LC-MS-MS. And then we're going to have some MBSTRN updates. So we're so excited to welcome Colin today, who has 15 years of experience in the field of life sciences using LC-MS. In his current role, he's a senior product specialist for the reproductive health team with a specialty in newborn screening diagnosis. In his prior roles, he worked for pharmaceutical companies using the same technology to find biomarkers in the fields of oncology, neurology, and inborn errors of metabolism, and ultimately the pursuit of novel therapeutics. We're so excited to welcome Colin today, who has a bachelor's in biochemistry and molecular biology and MS in pharmaceutical sciences and currently pursuing his MBA. So Colin, it looks like you have a lot to share with us today, and I'm happy to advance your slides for you. So thank you so much for joining us. We're so
Thank you so much for having me today. It's a great privilege to be able to speak to this community. This is something I'm passionate about, and I know that there's a lot of work to be done in this field, and I'm excited to share some of our work with you. As Amy had mentioned, we're going to talk today about measurement of I2S enzyme activity associated with MPS II. And I'm glad she said mucopolysaccharidosis for me, because that's a tongue twister. But we do that in dry blood spots using LC-MS. You can see my disclosures. I'm an employee at Revity, formerly the Life Sciences and Diagnostics Division at PerkinElmer. So what is MPS II? And it's also known as Hunter syndrome. So MPS II is a rare genetically inherited lysosomal storage disorder, and it's part of a family of the 7 mucopolysaccharidoses. There are other LSDs as well, but this is one of the families. It's among the most common of the MPS disorders, and it occurs in about 1 in 162,000 live male births, and it's X-linked recessive, which is why it disproportionately affects males. So it's characterized by the inability of the lysosome to break down glycosaminoglycans, also known as GAGs. And you can see down in the corner, I'm showing just an example of what that type of structure looks like, such as dermatan sulfate or heparin sulfate. And the I2S enzyme is responsible for degrading these in the lysosome. However, when a baby is born with an inability to break down the GAGs through the I2S enzyme, these GAGs accumulate. They result in damage to the nervous system, and I've listed only a few of the clinical outcomes of this, but they're very severe, such as mental impairment, speech difficulties, weak muscles. A lot of the patients have like an inability to walk, and then ultimately it leads to cardiac failure and a decreased lifespan. So what's really exciting is the RUSP nominated MPS II last year for testing of diagnostic testing, and as we all know, the RUSP is a central platform for recommending what needs to be screened for in the newborn community. So the good thing is there is a treatment for MPS II, which is often the case for things that end up on the RUSP. There's Takeda Pharmaceuticals has a treatment, which is Elaprase. It's not a cure, but it's an enzyme replacement therapy for the I2S enzyme. And as you can see in the topmost figure, administration after several months of treatment with Elaprase is able to decrease the urinary gags that end up accumulating in patients who are affected by MPS II. And not only that, we see that the decrease in some of the urinary biomarkers, but there's also, it helps to delay the progression of the disease and significantly improves the walking capability, which I spoke is a problem with MPS II affected individuals. This particular study was done in patients that are older than 5 years old, but this is speculation, but perhaps administration at a younger age could sort of halt some of this progressive disease. And that really speaks to why we're here, is that, you know, we need to be able to identify MPS II patients, and we need to find the right treatments for them, and hopefully in the earlier days of life. So how do we measure I2S activity? We do it in dry blood spots through LCMS technology. And what that looks like is essentially, this is more of the same, but basically what you do is you give a substrate into a dry blood spot that contains the I2S enzyme from the neonate. And in a healthy neonate, they're able to form a sufficient amount of product, as is to be expected. However, in the case of an MPS II affected neonate, the enzyme doesn't work well, and it forms a very small amount of product. So it's unable to break down the supplied substrate. So this is how we have designed our workflow. And on the left, you can just see some of the materials used. The substrate in an internal standard vial is worked up in the buffer alongside some controls that can give you some idea of, you know, low, medium, and high activity. And you can sort of just get an idea of what the buffer looks like, along with what the substrate and internal standard look like. In terms of the sample workup, basically a dry blood spot is punched, it's incubated with the substrate and the internal standard. It's left to incubate for some amount of time, and then the reaction is stopped, and the top layer is a liquid-liquid extraction is performed, but the top layer is transferred, dried down, and resuspended for analysis of the formed product by LCMS. So this is more of like what the actual analytical approach is. Essentially, we take 10 microliters of that finally processed sample. It's injected for a gradient separation by UHPLC, and it's monitored by positive MRM mode on a, at least in this case, on a QSight 225 MD screening system. And one of the important factors here is that the I2S substrate has a high propensity to in-source fragment. And as you can see by LCMS, for example, via chromatography rather, the product and substrate can be chromatographically separated. And that allows us to basically remove the contributing signal from the in-source fragment to the true product signal. And in the case of a neonate who's affected by MPS II, there is a lot of excess substrate left over because they're unable to catalyze the reaction. So the amount of in-source fragmentation is huge in that case, and we're unable to determine whether its true product or just the in-source fragmentation. So in the case of I2S, it's really important to be doing this by chromatography, whereas some of the other enzymatic reactions that you might be used to be doing by flow injection, they don't have that same propensity for in-source fragmentation, but here we think it's important for it to be chromatographically separated. So here we're demonstrating in the top panel, what we're seeing is on the left, the product is shown in the green trace, and the blue is the internal standard. In that same panel, you can see on the left is a normal neonate where sufficient product is formed, whereas on the right you can almost not see any product formed at all, and that is just a demonstration of how I2S enzyme activity looks like in an affected neonate. I do see a question from May Baker, which I will just field right now. If you go back to the previous slide for me, please. Each injection, you can see the gradient elution profile on the right-hand side, and it is 1.85 minutes sample to sample. So again, in the I2S deficiency state, there is very little product formed, and that's what one would expect. In the bottom panel, what we had done was determining the amount of time that might be necessary for incubation for sufficient product. Are in the blue. In the next panel, it's actually a confirmed I2S low activity sample, and then we have our controls, which are the low, medium, and high. As you can see, there's a spectrum of activity, and the I2S confirmed low are sufficiently low, especially even when compared to the low control. So there's really good separation, and this is true at either 3 or 18 hours. So at least for I2S enzyme activity, it's sufficient to, we believe that it could be done at least for 3 hours instead of a normal overnight incubation, which is done for some of the other LSDs. I did see another chat come through from Dr. Gelb. He'd like to point out that you'll be converting LCMS from via MS, which is true. So it is if one were to, and we're going to talk about it next actually, which is interfacing I2S with other LSDs. But finishing up his message, when adding other MLD CTX to the RUSP, you'll need LCMS, and there's no good fluorescent option. So I think Dr. Gelb is basically saying LCMS is the future for this. Okay, so as I was saying, I2S can be multiplexed in combination with other LSDs. And one of the ways that we have done it is using the commercially available Neo-LSD kit from Revvity. One of the things that you need to take into consideration, though, is the I2S does use a separate incubation buffer. So what we do is we work up the samples separate from Neo-LSD, and then later on in the sample workup process, we combine them together. So the benefit of this is, although you need separate incubation steps, they can be injected as a single sample on LCMS through that 1.85 minute chromatography method that I described. So if you're not familiar, the Neo-LSD kit, it's a 6-plex assay capable of testing for the following disorders: for Gaucher, and each of the enzymes are described in the parentheses. So for Gaucher-Krabbe, MPS I, Fabry, and Niemann-Pick type A and B, as well as Pompe. And again, per Michael Gelb's comment, the neo-LSD kit's a flow injection assay, but when combined with I2S, chromatography is required. So this is kind of just like what the assay looks like. Again, in just under 2 minutes, separation of all the 7 products. I'm only showing the products here, but the substrates are also chromatographically separated, as I had shown with I2S. In this study, we had compared just analyzing I2S alone versus in combination with neo-LSD, and that is the chart in the top right here, which shows that there's good correlation testing the same samples by a standalone assay or in combination with neo-LSD. And then the bottom figure is just kind of a different representation of the same thing, just showing the different activity in the different levels. So that's all to say that, you know, MPS II is due to the decrease in I2S enzyme activity, resulting in the buildup of GAGs, which are detrimental to development and growth in neonates. It can be well measured in dry blood spots using LCMS, and it can also, if you choose to, it can be combined with other LSDs in a single injection. And for some labs that are, you know, on a time crunch, they want their data faster. It looks like a 3-hour incubation does a really good job of separating confirmed I2S deficient neonates from normal neonates. So here is where I can take any questions or comments. I did see something come through the chat, which I have not read yet. Because the substrates are above the cam, could we do one incubation altogether? So the DBS buffers are actually different. And you can see the composition of the, in one of my earlier slides, you can see the actual composition of the I2S buffer, which is, let's see, I forget the exact ratio of things, but if you go back maybe one more slide, this one. So yeah, it's a sodium acetate and cerium acetate based buffer. So it has a different buffering system, and at least to my knowledge, nobody has found a buffering system that works for a combined LSD panel, including I2S. I have a next question, which is, did we use individual IS internal standard MPS II product standard to develop? Individual IS, and yes. So the I2S has, of course, the substrate that's supplied and forms a product, but there is a separate internal standard that is a component of the vial that is specific for I2S, and it's very similar to what the product looks like. Joe Orsini, can you
And Joe, you can unmute yourself if you want to ask the question.
Yeah, it's just a simple question of, do you have suggested cutoff ranges from your data?
Mm-hmm. You tell us the activity of affected. Maybe we can go back to that slide just so that we can kind of reference it. It would be, this is a backup slide for a time study for the other LSDs, but go, I think, go back. This one, yeah, this one, yeah, sorry, the next one. Yeah, this one gives a pretty good idea. This was only in about 1,000 patient samples. And you can see The median in the 3 hours is about 27. In the 18-hour, it's about 17. And of course, I want to remind people that the way that we arrive at activity values are that it's divided, it's micromolar per hour. So every time we add time, it's going to sort of make it look artificially like the number is going to be lower because we're dividing by a higher time value. Because most of the enzyme activity happens in the early stages. So it looks lower at 18 hours for that reason. But as you can see, there's at each individual time point, you can get an idea of what, at least in this study, that we have shown for I2S activity.
Thank you. May, do you want to unmute and ask your question?
Okay, yeah, I just because Colin, you mentioned that adding on the MPS II, I2S enzyme, you would need to change it from fluid injection to LC. I just curious, the overall, the runtime will change.
The runtime will change.
Longer, right?
It's longer, yes.
How much?
I would say it's sample to sample, like for example, by neo-LSD is about like a minute, and this is about 1.85 minutes. But also there are some benefits beyond just the time, like the time's gonna be longer, but there are some benefits. Like for example, with the column in line, you will sort of have a cleaner injection into your mass spec. And also, even though it's not as big of a problem, something like Crab-A with Galc, that also likes to in-source fragment a little bit. So you can also separate the substrate and the product. So you can also, in addition to adding I2S, you can sort of separate out some of the substrates that affect the other LSDs as well.
Thank you.
Dr. Gelb, did you want to unmute yourself and make a few comments, or I think we're following your chat also?
Yeah, I agree with everything Colin said. I think you did a good job. I think the jury is still out on whether you can combine MPS II and neo-LSD into one buffer. I think Joe Orsini in New York was going to try that. He hasn't had a chance yet, and we have some data suggesting that it might work, but I think you'll take a hit in activity. So I think the jury is still out. I want to dispel a rumor which I keep hearing about, that over and over again this rumor keeps repeating, and it's just not true. I mean, it sort of is not true. The idea that the MPS II product is the MPS I substrate. So some of the MPS II product would get eaten by the MPS I enzyme if you get well, in general, 1 or 2 buffers. But this is not a problem, because it's true, the MPS II product is the substrate for the MPS I enzyme. And in fact, this is true for all of the LSD assays. For example, the Gal-C product is ceramide, and that's a substrate for acid ceramidase, also in the blood spots. Same for Gaucher. So the reason you get away with this and you don't gobble up all your product and internal standard is because you're making very low micromolar concentrations of these products when you use a blood spot, and you're way, way, way below the KM for the downstream enzyme. And so the amount of product that gets consumed by the downstream enzyme is a few percent or something like that. It's not a lot, and so it doesn't really amount to anything. Now you might say, well, wait a minute. When the activity of the enzyme is low, like in a true LSD patient, you might start bringing some normals into the affected range because, you know, this downstream enzyme is going to reduce the activity at the low end a little bit, and it could increase your false positives by bringing the non-LSD patient below apparent activity into the affected range. But this is a non-issue because this is built into your cutoffs, right? So everything cancels out. So it doesn't really matter if a few percent of your product is converted to something else by a downstream enzyme. It's true that it happens, but it's just not, it's not something to worry about, okay? It's all built in, you know what I'm saying? It's built into your cutoff. I hope that's clear. You have to remember, yeah, that chemically the product is a substrate for the downstream enzyme, but you're using millimolar concentrations of substrates in these assays, and you're producing low micromolar amounts of product. And so, you know, you're way below the KM for the downstream enzyme. And so that slows down the rate to the point that essentially none of it gets consumed, okay? So I want to kill that rumor that this is a problem, because
Thank
it was
you.
started by, yeah, okay.
Thank you,
I hope-
Dr. Gelb. And we're recording this, so we'll do what we can to get that out there, that that's
we
not
have all
what
the data, and it's just, it's
Yeah.
not true, it's no problem.
Yeah,
Yeah.
thank you. Dr. Ellenwood, you put in a comment at the beginning of Colin's talk. Can you tell us a little bit about the new categories for MPS and how we can all get up to speed and use the updated terminology?
I'm sorry, I'm a little bit of a pedant, I'm afraid. So this is a new MPS that was just discovered last year. I think there was an animal model data going back to the 2017s. It's aryl sulfatase K deficiency. It yields a dermatan sulfate storage disorder. I have a nomenclature issue. It really probably ought to be MPS 6B, because following the approach of keratan sulfate storage disorders being 4A and 4B, if you have a dermatan sulfate storage, it should be 6A. But they've called it called it MPS 10. Aryl sulfatase K deficiency, later onset. They don't actually have glycosamino glycans in the urine probably until pre-adolescence, but clearly you look at the pictures of patients, they look like mild Bartholomew syndrome patients.
Thank you. If you have a link to anything that we can follow up on, you could put it in the chat for everybody.
I can give you the papers and get them into the chat.
Oh, super. Thank you so much. So Colin, you've got quite a bit of conversation going amongst the attendees, and I just want to make sure that Dr. Wong's question got answered. It's the last message in the chat window if you want to glance at it before we.
Oh, sorry, I had not seen that.
Yeah,
Not sure you do this.
I think he's looking for a single IS internal standard.
You can use IS who's chemically identical or product with deuterium. Sorry, I'm not sure I understand the question.
He wants to be able to get a sample of MPS II internal standard without the substrate mixed together.
Oh, I see. I mean, that's technically possible. It's not one of our like part numbers that we supply, but yeah, I mean, obviously it's just a matter of not mixing them together. I
mean, if you want a small amount for a few time, I can send you some, but I mean, it won't be, I'm not going to speak for PerkinElmer whether it'll be available on a long-term basis, but if you want a small amount for a research study, I can send you some. So
I know that
yeah.
From our side,
I can't sell it to you. I can't sell it to you, but I can give you some. Yeah.
Yeah, I know from our side, it's not something that we are offering. But yeah, I mean, it's technically feasible. Yes, of course.
Yeah, either way.
And Colin, if you're open to it, you could share your email in the chat window in case anybody wants to follow up with you, or you can always send a message, everybody, to mbstieran@mbstieran.org, and we'll get you in contact.
I know a lot of the people participating on the call, but for those of you who don't
Yeah.
know me, I can be reached at colin.hill@perkinelmer.com, at least for now, and then it'll be colin.hill@rivity.com. But I will share my email, and if anyone wants to reach out to me for any reason related to I2S or related to any other newborn screening initiatives, I'd be happy to have a conversation about it.
Great. Well, thanks so much, Colin, today for your presentation and
welcome.
fostering a lot of great conversation between the attendees. So moving on in the agenda, so we'll spend a little bit of time on MBS TRN updates. And then I want to take a minute to remind everybody of the long-term follow-up cares and check initiative, and then talk about some new awards that are really exciting for all of us in the newborn screening community. So Key, I don't know if you want to talk a little bit about Dr. Powell's podcast that just launched.
Yeah, hi everyone. So I'm very excited to share that we interviewed Dr. Cindy Powell, who's actually here today on the webinar. And as we know, she plays such a vital role as the past chair of the U.S. Federal Advisory Committee on Heritable Disorder in Newborns and Children. On this podcast, she shares her career journey and also updates about the early check program and her project NC Nexus on the findings and the future initiatives. So definitely please take a listen to the podcast.
Thanks, Key.
And
yeah.
and we're really excited that we have our newborn screening research summit that's scheduled for September 13th to the 14th, which is Wednesday through Thursday from 12 to 4 p.m. So everyone, please block out your calendar today. We'll be sending out more information through our newsletter, the registration information. But our newborn screening network meeting which just occurred in the month of May, we had over 500 people register, and it was a big hit, and we had such a great lineup of speakers. So we anticipate another big hit with a great lineup of speakers. So definitely spread the word and RSVP onto your calendar on these important dates. Thanks.
Thanks, Key. So Jekka, do you want to talk a little bit about this important survey that everybody could participate in?
Sure. Hello, I'm Jekka. I'm staff liaison for the Bioethics and Legal Work Group. And so as we know, researchers have many challenges in LC, the ethical, legal, and social issues when it comes to newborn screening research. So we really would appreciate everyone, sharing this link, this QR code with your colleagues, your network, because the more data that we have on this, the better we will be able to, at MBSTRN, we'll be able to assist and help researchers in their, current and future projects. Thank you.
Thanks, Jekka. And I think it helps the newborn screening research community work with the state newborn screening programs, advocates, and clinicians. So we're really excited to see what kind of great ideas you have for all of us. I want to take a minute to talk to you or remind you about a project that ACMG was funded by HRSA to conduct. So HRSA for a long time has been funding long-term follow-up initiatives. And 2 years ago, they funded 6 different sites or 6 different projects to tackle long-term follow-up in different ways. So ACMG, with myself as a director, was one of the awardees of that 2-year effort. Our effort was called Long-Term Follow-Up Cares and Long-Term Follow-Up Check. The CARES component is a data collection tool, and the check component is designed for state programs, whether or not they want to actually collect the data or just consume the data and understand for each condition what kinds of outcomes would be important to look at. On the research side, we're all challenged by the number of conditions that are candidates for newborn screening, as well as all of the newborn screening programs are challenged by just the difference between each of the conditions that are screened for. So the check is designed to give you a disease-specific look into health outcomes. And so we're really beginning to leverage what the newborn screening system fosters, from early identification and in some cases pre-symptomatic identification to long-term follow-up, to be able to maximize health outcomes and to determine what leads to better health outcomes across the United States. No matter where you're born, you're offered essentially a newborn screen, but we know that the time to diagnosis, the kinds of treatments, the kinds of intervention, and the kinds of support that parents and families and individuals impacted by a newborn screening condition get vary across the United States. We're just beginning to understand how those differences lead to different outcomes and how we can all work together as a community to improve health outcomes across the board. So our project was one of the unique projects funded by HRSA where we include a focus on parents and families. So we ask parents, what do you think is a good health outcome in conditions that are part of newborn screening? For our demonstration project, we chose spinal muscular atrophy, and Dr. Swoboda is one of our lead experts who's helping guide our study and sort of help us think about, you know, as a clinician, there are potentially different focuses for health outcomes than for parents and families and state newborn screening programs. So we wanted to be able to articulate that a little bit in this project and to understand what is important to parents and families. Increasingly, we're also interested in what's important to communities as they work to support these families that have a newborn screen identified family member. We've got many partners, so thanks to Dr. May Baker, I see her as one, and Dr. Swoboda who've joined this. We have 7 clinical sites who are going to be actively entering data, and they will be entering long-term follow-up data, but doing it retrospectively so we can get a report on the first year, the second year, the third year, and the fourth year of life for newborns identified through newborn screening with spinal muscular atrophy. We also work to pair state newborn screening programs with those clinical sites. And out of the 7 clinical sites, we were successful to pair 5 state programs. So the other state programs that were interested in this particular project maybe had already been conducting their own type of long-term follow-up or just didn't have time to participate. As a team at ACMG, we will be delivering the long-term follow-ups information on long-term follow-up check to all the state newborn screening programs across the United States. We also are joined by several technology partners who are helping us think through not only how to collect data, but how to visualize and monitor data over time and to share data. So we're sort of thinking of some new ways to do that. This is a little bit of the workflow. I said the long-term follow-ups care component was really about data collection, but we're also really focused on how you use the data, how you can get snapshots of the data, sometimes called data visualization or dashboards. Our idea at the beginning was that clinicians are really the source of the data, in addition to parents and families, but our focus is on clinician entered data that then is available for visualization by state newborn screening programs so that state programs can log in and understand how the children in their state are doing based on these parent-informed health outcomes. We have a website for this project, long-term follow-up mbs.org. So we invite you to check out the website and even to join the project. We still are working on the project over the next year, and we'll be working to put together the learnings and the findings so that we can move from SMA to all of the conditions that are part of newborn screening. I also wanted to take a minute to say congratulations. Many of us received an announcement from Dr. Jeff Brosco about the HRSA Division of Services for Children with Special Healthcare Needs Awards that were recently awarded in 2023. There were 3 big groups of awards. The first one was to the American Academy of Pediatrics, and this is to develop a national center for children and youth with special healthcare needs. And so as you can imagine, I assume long-term follow-up and newborn screening will be important components to that effort. So I know all of us will look forward to seeing what AAP has in store for as they work through developing this program. Many of you on the line, congratulations personally. All of the purple states were awarded, as well as some of the territories were awarded the Division of Services of Children with Special Healthcare Needs new awards under the MPS Propel, which stands for State Newborn Screening System Priorities Program. And so we're really excited for each of the states and territories. There's 28 in total that received these awards. So we'll be excited to hear about your plans and see how we can help out at ACMG and MBSTRN as you work forward. We also want to congratulate our partners over at APHL. They were awarded MBS Excel, or the National Center for Newborn Screening Excellence. And so we're really excited to see how they're going to use this funding and their work with the 28 Propel awardees to advance newborn screening. So congratulations to Jalili and the team over at APHL. So just a reminder that the ACMG team is here to help as you develop your new awards, whether you're a state or a colleague at a pediatrician or at APHL. We've got a big focus in long-term follow-up, as well as helping with RUSP nominations, pilots of candidate conditions, and really working to understand the conditions that could be part of newborn screening. Coming soon, Jekka Key and the rest of the team have been working hard on an update to the LPDR. And so the longitudinal pediatric data resource, many of you know well. I want to update you that there are 61 conditions that now have common data elements or question and answer forms that are ready to be used for long-term follow-up. So that's 61 conditions. Many of them are RUSP conditions, some of them are candidate conditions, and some of them are sort of focused on healthy populations. Out of those 61 conditions, there are 41 conditions that actually have data available. 41 conditions that have at least one subject that's part of the data collection longitudinal effort. And about half of those, a little over half, have more than 5 cases. And I use that 5 number as a cutoff because that's what we've determined in our bioethics and legal work group. It's sort of the cutoff for being able to share de-identified data. So on this screenshot, you can see that we've sort of reorganized the LPDR into being organized by the condition names. And for each of the conditions, they're organized by whether they're part of the core panel on the RUSP, core or secondary, or whether they're a candidate for newborn screening. And then we list how many studies are available. And the studies always have a data dictionary or a list of question and answers. And then some of the studies have actually question and answer sets that you can use for your work. I want to give a preview for our August meeting. We'll be giving an update on efforts for genomic sequencing in the neonatal period. We'll hear an update from Dr. Holm on BabySeq2 and from Dr. PA from RTI on early check. So both of them will be speaking for about 20 minutes each, and then we'll have a question and answer session on our August 3rd meeting. So with that, just a reminder that all of these calls are recorded and put on our YouTube channel, and we welcome any feedback that you have from us as you work to advance newborn screening. And with that, I know we have a few minutes left, so if anybody has any questions for the ACMG team on our efforts, we'd be happy to talk through them. Oh, great. Thanks, Nicholas. Do you want to talk a little bit about what you guys are looking for?
Hi, everyone. Can you guys hear me?
Yep, we can hear you.
So thank you for the opportunity. Yeah, put that. So we were one of the states who are funded. We are really happy about that. And we would like to hire someone who will work with me for assay development and more in general. So the main focus would be to multiplex LSD in our current assay, but also to work on the, this kind of idea we can have for AAAC, which this flow injection analysis, it's not perfect. And we also have some idea, to improve this assay. So the idea would be to have someone work in the mass spec and, to have more idea and more power, hand power.
Great, thank you. Yeah, go ahead, Matthew.
So I'd like to make an announcement that the National MPS Society is seeking seed money grants for programs that can lead to RUSP enabling pilot projects for MPS 4A, 6, and 7. I've posted the Proposal Central grants portal in the chat. You just need to go in there and search for National MPS Society. It is a very low stress 2-page letter of intent due July 7th. Does not need budget or signatures. July 17th, excuse me. And you can also contact me at Matthew at mpssociety.org as well.
So that, Matt, that's for prospective pilots with identified blood spots, right?
It is for this, the most we can fund is up to $100,000 with the renewal, so $200,000, but that is a competitive renewal. And we know you're not going to be able to get going a prospective pilot. This will be research at any level that will lead to a pilot that could be RUSP enabling for MPS 4A, 6, or 7. So wherever you are along the prospective path, we are interested.
What was the deadline? July 17th?
July 17th, 2-page LOI.
Thank you. Anybody else giving away positions or money? This is great. So Dr. Svoboda, how was Cure SMA?
I just wanted to ask a question before that, and about would it be worth, or have you already done a dissection of what happened with Duchenne? Because I mean, that was very controversial, and but it came very close to passing. And I don't know if it would be worth talking to the people about dissecting a little bit for the people who weren't there during the meeting, and understanding, you know, what are the next steps, and what were the weaknesses and strengths of the proposal. I have my own thoughts on that, and I breathe a little sigh of relief, to be honest, that it didn't go forward yet. But
yeah,
any plans to do something like that?
Yeah, I think that would be a great actual topic for this meeting. I think that's what you're recommending. I don't think Nikki's on today, who led the effort at PPMD, but we did, ACMG was part of the RUSP nomination, and the committee did ask, the advisory committee asked some specific questions and for some clarifications. And so we did resubmit the nomination. So we think in August it will be discussed, but I agree with you, Kathy. I think what happened during the RUSP nomination for Duchenne is informative for all of us. And sort of when is something ready for prime time, things like that. So I think that's a great topic.
Yeah, and also the fact that the new gene therapy for Duchenne was not approved to be given until age 4 now, and how is that going to play in, you know, to this? Because that's a big deal to identify newborn, and then, okay, well, you know, nothing's going to be available yet, but when your child turns 4.
Yeah.
But anyway, I would love to hear that discussed in a little more detail before it goes back to the actual meeting discussion, because I think we could all sort of learn from that. But regarding the Cure SMA meeting, it was fantastic as usual. You know, there's just so much happening though in the clinical space about combinatorial therapy, and we've just got to capture this data. And I think that becomes clearer with every day, that we just need as much long-term follow-up data across the country, because it's just becoming astronomically expensive and the outcomes are uncertain, and we're committing these babies to 2 therapies now without an escape strategy for when we would take them off. More is not always better, you know, and that's the problem when we have a glory of riches. We have 3 therapies that can all be given now to newborns. And, you know, that might be worth a whole separate discussion, you know, as opposed to, you know, the usual rare disease stepwise thing started happening before newborn screening was authorized. And now it's a little bit free for all, Wild West out there. And, I know that Mary Shore, I don't know if she's still listening or still on, but, I think they're doing the best they can collecting data from some of their expert sites. I know there's lots of initiative with what you're doing, but it was really great to be there and think about this a little bit more with my colleagues. So thank you.
Yeah, that's really interesting. May, do you have something to add or do you have a new question?
I just want to adding on quick about SMA, Kathy. I think it's still kind of jury out there is when you have a SMA 2, combination 5, what you're supposed to give the gene therapy or something else. Now you have choices now, right? So if these things be connected, I think it's so helpful because I know some people give the gene therapy for the SMA, the 2 combination 5. I thought will be interesting to collect this kind of data.
Oh, absolutely. And there is controversy. I mean, I personally, we get in a lot of our reports, if they have 4 or more copies. Now that we're getting reports of 5 copies, that's going to be more challenging. But there's not a clear relationship between that copy number always and what that baby's going to do. And you're potentially, in my opinion, and Brunhilde Wirth made this statement at the meeting. She's a scientist who's followed this for a long time, on the basic science side. The test that we have for determining exact dosage is not perfect, but we do know that 4 or more copies, in the clinical population that was identified before newborn screening gave you a much better chance of having a milder phenotype, but still most of those kids presented in childhood. And with my personal experience, I've had 2 4-copy kids not get treated until teenage years and then rapidly progress. And it's too late to fix it by that point. Because it's selective muscle vulnerability, selective motor neuron pools. And if they haven't been followed up every single year, we get lackadaisical about that. I think the programs that Cure SMA are putting in place to make sure those kids don't get lost are good, but families are going to walk away and not want to see a doctor every year if their kid's fine, is the bottom line. So.
Mary, did you want to add something about the meeting or your efforts on sort of collecting that data?
So I agree with Kathy. We were very pleased with the meeting. It was fabulous. We had over 560 researchers and healthcare professionals who were there contributing. There was a lot of engagement, a lot of discussion. I expect from that meeting that there will be lots of next steps to move all of this forward. Cure SMA is collecting through their care center network, collecting clinician entered data to try to better understand treatments and outcomes. There's just, like Kathy said, it is a bit of the Wild West out there and it's driven by multiple things, parent, patient desire to have best outcomes, as well as clinicians. It was interesting to me that one of the things that came out is that clinicians also need to reset expectations. It's not just families who have high expectations for these treatments. We're still learning as we go. It's just it's critically important that the patient caregiver community partner with the healthcare provider so we can learn as much as we can. Mm-hmm. Yes, May, we definitely need to talk. I know. I'm sorry. We literally just got back from conference Sunday, Monday of this week, and we're still recovering. So,
well, you and I supposed to meet. We haven't yet, right?
Yes. I'm sorry. That was my fault. That was totally my fault.
Okay.
But I was starting to write my email to you during this meeting. I mean, we're just so pleased with all the initiatives that are being put forward by this group. This is wonderful. I had another point, but you know what? I lost it. So thank you for everything people are doing about SMA. We know that this is a disease that really is cutting edge, and a lot of other disorders are learning from this disease. So there's a bit of pressure, but there's also lots to learn. Oh, I remember what it was. So Kathy, you were talking about 4+ copy kids. There is a publication talking about expert opinion regarding treating kids, at least in the US, up to 4 copies of SMN2. the outcomes of those 4-copy kids is so variable clinically. And one of the points that came out of our meeting was that we know the tip of the iceberg about the genetics. I mean, we know that it's, you know, it's a monogenetic disease, but there's a lot of modifiers that have not been identified. Why is a 4-copy kid, you know, clinically can be anywhere from a type 2 or sometimes even a type 1. I've had 4-copy type 1s who were kind of on the border, up to being an adult onset. You know, we really need to understand these modifiers better. So this just, we know a lot, but we know so little at the same time.
Yeah, I agree. I think somehow staging them once they get a higher copy number might be like, what other tests do you then look at to confirm what kind of risk they have? Are there modifiers we can look at? Are there secondary other tests like neurofilament or CMAPs or whatever? So anyway, you know, I think there's a lot of work that still needs to be done, and but it's very exciting to see the progress. Someone asked in the chat about which one's better. You know, it's not about, no study has compared each of these side to side in you know, it really has to do with timing, you know, where the kid starts with, and there's so many variables, right? And so, you know, I think that families are choosing gene therapy as the best. But then if it takes too long to get it, sometimes they're second guessing that, and that's where the secondary therapies get added on. It's a problem.
I would reframe it a little bit. I don't know that, so the advantage of the gene therapy is that it is a one and done. The other therapies are lifelong. We don't have head-to-head which one's best. The other thing to take into consideration is that there are risks with each of these medications. None of these available treatments are perfect. They have side effects. They have considerations that families really need to think through. So it really is a healthcare provider, caregiver, patient conversation to decide for that situation, what is the best treatment going forward.
And it's so great to have that conversation as it's sort of evolving. But I think one thing we've heard from the newborn screening programs is, you know, it's sort of like time from screen to diagnosis gets really short with SMA. And I think, as you pointed out, Kathy, what we can learn from Duchenne, it would be interesting to hear what you guys think we need to learn from SMA. Not that SMA is not a fit for newborn screening, but boy, is it really challenging the system. You know, and it was multiplex with SCID, so it had a little bit easier implementation potentially. But now, as Dr. Baker does in Wisconsin, there's a copy number plus the, you know, SMN1 gene deletion. You know, so it's very instructive. If you ever all catch your breath, maybe we could put together sort of a lessons learned, right?
And there's 3 to 5% that aren't picked up by newborn screening with the current genetic testing. So
Yeah.
I mean, there's that too. So
yeah, I can't wait to see more. But I just want to say to Amy, every single patient is better off than they were natural history. Every single one that starts, even if it's later, even it's, you know, that's very obvious. They're all home runs. They're just, we just have to look at a lot more to figure out how to fine tune.
Yeah. I know one thing, and I know we're at the top of the hour, but one thing with HRSA and the new awards looking at long-term follow-up, they're very interested in what's called loss to follow-up. In general, Mary and Kathy, do you feel like that's an issue with SMA? You know, I feel like SMA is almost like SCID, where that first year of life is so intensive with medical intervention that maybe in the first year you really don't lose anybody. But you guys have any predictions for us, or what do you think?
So from the Cure SMA perspective, we work very hard to keep those families engaged with the SMA community as a whole, Cure SMA as an organization, and with their healthcare provider, stressing the fact that it is so important that we learn together what the long-term outcomes of these medications are. We have 8 years of, you know, Zolgensma experience. We have 10 to 12 years of experience with Spinraza. There's just so much we need to learn. So it's a concern, it's a risk, but we're doing, as much as we can as as a patient advocacy organization to keep families engaged at all levels.
I would just add that the biggest risk to follow-up is this one and done gene therapy model, which is not really the best model, because when these kids get to teenager age, we don't know what's going to happen. We don't know the longevity. We don't know how many motor neurons are going to continue to be stressed. Are they going to lose any more? And that to me is the biggest risk. And, we've lost a couple families when I left academic medicine to kind of and switched patients to hospitals. A couple of the gene therapy patients aren't following up because their kid's doing perfectly well. And I'm encouraging them not to do that, but that's my concern.
Yeah, that's interesting. We're gonna have to try to keep LTFUs straight, lost to follow-up or long-term follow-up, but we can work on it. Lost to follow. Thank you everybody so much, and we're really excited again for the new awards across the board and to learn how they're going to impact the work that we all do. And thank you so much everybody for being so engaged, and please join us in August where we'll have a genomics discussion, but I'm going to follow up with Dr. Swoboda about the idea of talking a little bit about the RUS implications from Duchenne. So have a wonderful day everybody. Thank you so much.